I said, for our categorized classification, we are going to use OpenStreetMap. Okay. So in XYZ tiles in your browser panel, you will find OpenStreetMap. Okay. So just drag and drop the data. Okay. For now, those who don't know where Ahmedabad is, use plugins, go to geocoding and write Ahmedabad. Okay, we are going to use Ahmedabad for our categorized classification. Okay, so use the first option and it will direct you to the location. Okay, so zoom in using your mouse scroll and go to Ahmedabad district in Gujarat. Okay, so this is going to be our study area for today. Okay, so let's switch off this geocoding plugin results. I hope you all are able to get this OpenStreetMap. Okay. Okay, so now we are going to load some data and we will see how we can classify it using categorized classification. Okay, so basically your categorized vector style classification applies to one symbol per category of the attribute values. Okay, let's see how it works. So when you have installed your Quick OSN plugin, so it looks something like this. Okay, right? So click on it. Okay, so as soon as you click on it, you will find map preset, quick query, OSM file parameters and about. Okay, so click on quick query. Okay, so now we will query our OSM map to get some data. Okay, so this map has some digitized data that we can use for our analysis. Okay, so here you have to provide key. If you don't know the key, you don't know what is the key, then you can use this drop down menu here and see what are the options available. Okay, so for example, you can get data on bicycle parking spots. Okay, you can get data on bridges, right? In the same way, you can get data, like you can get all these data, clubs, okay, construction, right? So these are all type of vector data that your OSM can provide you, okay? But the limitation is this data is not available for every site, okay? Only the major cities or you can see the metro cities or maybe some tier 1, tier 2 cities, the data is available but not for the every site. Okay, so you can get, so the data that we used in our second day of New Delhi region, I downloaded that data in the same. Okay, so if you remember that data, you can you will be able to correlate it. Okay, so first key that we are going to use will be building. Okay, so I'm going to use some building data in this region. Okay, so in value, if you will come here, whether you want apartment type of buildings, you want commercial, you can mention that. But for our classification, I will leave this value field empty. Okay, I won't give any value because I want all this data. Okay, so please just tell me if my speed is fast or is it fine. Any one of you can mention that.
Yeah, ma'am, it's fine.
It's fine. Okay. Then let's move on. Okay. Right. So I hope you have understood the meaning of this key and the value. So based on the key, your OSM will fetch the data. Okay. So we want building data in this region. So now here you have to provide the extent, spatial extents. Okay. So in which region you want. So you have different options. So you want in and around something. If you have loaded some data here, okay, loaded some point data or some line data, then you can go with around, and here you will give that option to select that particular layer. Okay, so in and around 1000 meter, right? In this way. So you can also use the canvas extent. So this will take the extent of the map that you are able to see on the map canvas. Okay, map workspace, right? And you can also, if you have provided some layer here, then you can go to layer extent as well. Okay, and also you can get some non-spatial data. Okay, so I'll use the canvas extent because we do not have any layer to provide reference, right? So I'll use the canvas extent, right? So after this, you go to advanced. Okay, go to advanced and click on all these things. So this is the nodes in the data. Okay, when two points are meeting, like it form a node, right? So let's download all these things because sometimes some data have this relation they and nodes, right? These are the advanced features. If you don't take this, then your data won't be loaded. Okay, so this is the relation between two features. So this is something to do with the way, okay, the way in which data is made, right? And here, if you want point data, line data, multi-strings or multi-polygons, okay, so you click on all these things. If you want its metadata, okay, so the data in the tabular form, okay, all the information about that particular data, you can click on that as well. Okay, so once you are done with this advanced setting, then after that click on run query. Okay, click on run query. So it will take some time to get you some data. Okay, so if I'll move this window here, you can see all this buildings data is generated in the, there are some points, there are some these lines and some polygons, okay, representing different things. You can check these things in its attribute table. Okay, so next key that I'm going to use is land use. Okay, you can also get some land use data from here. Okay, land use, right? So I'm going to use canvas extent. Okay, keep the advanced setting in the same way because as we all know that land use is mostly it is polygons, but let's keep the points and lines and let's see, we can delete them later instead of not, keeping them off, and there will be then sometimes OSM is not able to extract the data. Okay, so just keep all these things in as default and then again run query. Okay, okay, so in this way you can also get the roads and highways and all this data. Okay, so this is the history. Here you will get the history of the queries that you put here. Okay, and when you come back you can directly use this play button and your query will be will it will run and you will get the same data. Okay, so I hope this window is clear, so I'll just close it now. Okay, so this is your land use. Okay, this is your different type of land use in your canvas extent. Okay, and here you have some point features in the canvas extent. We don't need this. So these, if you look into its attribute table, so it has got some node. Okay, some entrance, even ground. Like these are some of the attributes that these points. So these are just 4 points. Okay, so we don't need such data. Okay, we can delete it, remove there, click on OK, right? In the same way, we don't need anything, any polyline and points for our buildings. Okay, we just need the polygons. So you just remove these here, right? So yes, so this is our land use and buildings data. Okay, so let's keep our land use at the bottom. Use the categorized classification. Okay, so first I will use the land use and let's see its attribute table first. Okay, so I think you will recognize that or you will remember that this table is similar to the table of New Delhi region. Okay, so it provides you the list of different land use. Okay, retail, residential, and all these things. Okay, and recreational town. So we will classify our data based on the land use in the region. Okay, and we will use categorized classification. So for that, you go to layer styling, open the layer styling panel. Okay, and in single symbol here you change it to categorized. Okay, and here you have to provide the value land use. Okay, then use classify. So it will give you the data on different type of land use. Okay, so only this much of data is created in this Ahmedabad region. See, there are so many areas which are not, which are not vectorized or digitized. So this is basically digitized data. Okay, you can also contribute to that particular region, right? So yeah, so this is your different type of land use. So let's also categorize our buildings using categorized classification. Okay, and here I'll go give it as building. Okay, then classify, right? So these are different type of buildings. Like there are some depot, there are mosque, there is residential buildings, there are schools. Okay, so they are represented by different colors. You can also choose color ramp of your own choice. Okay, you can use whichever color ramp you want. Okay, in this way. So basically this vector style is the best when you want a different symbol that is based on the attribute value. Okay, so each attribute value gets a different symbol. Okay, and such as when you are styling country polygons or maybe land use. Okay, and soil type or some administrative boundaries. So when you want to give uh, different color to each attribute, so use categorized classification. Okay, I hope this is clear. Okay, so if you further want to add texture to this, you know how to do that. Just click on it. Okay, so click on it, double click, and click on simple fill. Right now, you want how to add layers, and you can make it more interesting. Right, you can give them different textures, different patterns if you want to. Okay, graduated vector style. This is going to be our second topic. Okay, so let me remove these two layers. Okay, for graduated classification, I'm going to use the data that we used yesterday, which was about the census data. Okay, so let's drag and drop, and again we have to create a filter. Okay, we will work in the same district. You can work on other districts as well. Okay, I will use the same district and right click here, click on filter, and district code was 1. Okay, click on OK, and we got the same data. Okay, now, so there are three type of concepts that we are going to learn today. Is that your graduated classification? It actually applies one symbol per range. Okay, here you get the range. In categorized, you don't get the range. Here, if you want to give a range to your data, then you use graduated classification. Okay, of this numeric attribute values. Okay, so this vector style is best when you want a different symbol that is based on a range of numeric attribute values. Okay, such as when you are doing when you are working with the census data or city population data. Okay, so let's see. So we know that what is there in the table. Okay, we have all these attributes. See, like I have deleted some of the unnecessary columns. You can also do that by clicking on this window and using this delete field option. Okay, you can do that as well. So I have deleted some of the unnecessary fields for my convenience. Okay, just for the convenience, right? So here today we are going to use total population, right? And population literate. This is total population that is literate in each polygon, okay, or in each village or district boundary, right? And this is your male literate, and this is your female literates, okay, and this is the area of each polygon or each village, right? Each administrative boundary, let's say. Okay, so now I'm going to use all these columns. Okay, so first let's classify our values with the using the first that will be our first way of classifying values. Okay, I'll go with graduated, and in this case I'm going to use total population. Okay, just classify. Okay, so this gives you the range of values. Okay, range of numeric attributes, right? So this is where your your graduated type of classification works. Okay, so this is the simple, right? population, literate population. Okay, if I use this category, right? So this actually gives you the count of total literate population. Okay, total population that is literate in each polygon. So choropleth maps are a type of your thematic maps that shows the proportions or rates instead of your raw counts. Okay, so you need to normalize your data, okay, out of the total data in order to show the actual distribution. Okay, so when you are talking about the population density, in that case you need to normalize your data with the area of your polygons or area of the region for which you are counting the for which you are calculating the population density. If it is not clear at this moment, theoretically, let's understand this practically. Okay, so basically this choropleth is a word that is derived from Greek, okay, and in which choro means area and plethos means multitude, or multitude means a large number of people or large number of things. Okay, so basically this map plots a large number of items in an area. Okay, and it uses proportions and rates. Right? Let's see how it is done first. Okay, so choropleth maps are basically for univariate, okay, in which you use only single variable, okay, only one variable, and choropleth maps also can be created using two variables in a single map, okay, using the polygons, using the ratios of two polygons data, okay, two type of data, right? So let me remove this diagram. I'm sure only 50% of the things are clearer at this point. So just wait for some time and let's make map. Okay. So this is your map with the raw count. Okay. Let me just rename it so that later we can compare it. Okay. I'll just write raw count on total population. Okay, let's make it like this. Right. So I want to duplicate the same layer because we want to create our univariate choropleth map for the same area. Okay. So for that I will duplicate this layer. Let's duplicate this layer. Okay. So the duplicated layer will come at the bottom. Okay. So let's keep this layer at the bottom for now. Okay, okay, and you will see this layer now. Okay, I'll close this and we will work on this one, right? So as I said, choropleth maps are more useful, more informative if we talk about the census and population density or any type of rates you want to calculate. Okay, so for that let's calculate some rates. Okay, let's calculate the total literacy rate first, okay, because we are going to use single parameter, right? So what I will do, I will go to expressions here. Okay, I'll go to this E button which is called expressions. Okay, so with expression you will get this window. Okay, and your literacy rate formula is so start with a bracket. Okay, here you have the options of bracket, so double click here. Okay, total population, total literate population divided by total population. Okay, so how you are going to use the field of total population? For that, in center part, in the center highlighted region, please find this fields and values. Okay, so go to fields and values, click here. Okay, and here you have total population. Okay, you have total population, double click on it. Okay, double click, and after that close the bracket. Okay, and this ratio of total literate population out of total population should be multiplied by 100. Type 100 using your keyboard. 100. Okay, it should be multiplied by 100. Okay, I hope this formula is clear. Literate population divided by total population will give you literacy rate, right? So this is a very simple simple formula, right? And after when you have created this formula, click on OK. Okay, have you all noted down this formula in your notes? Okay, so please use this formula. Click on OK, right? So see, now here you have provided the value based on some expression. In your projects, in your work, if you want to do the same, if you don't want to calculate, you don't need to create field every time in your attribute table, okay? Right? So you can do that as well. Okay, you can go to the expressions, okay, and create the formula here. You have everything here, right? So whatever fields and values are there in your attribute table, you will find in the fields and values, okay? But if you can't remember all these things, then but if you remember the field name, you can just type here p underscore lit, okay? So in this you will find it, okay? In this you will find that particular option, okay? I hope this formula and expressions is clear. So then after that click on OK when you are done writing the formula, right? So now earlier we were just using the direct value. Here we have calculated our own parameter, right? So after that again click on classify. Okay? Click on classify, right? So let me give it three classes, right? And you can change it to natural breaks or any sort of like parameter, okay? So this is your literacy rate, okay? Let's rename it again. Let's rename it to literacy rate, okay? Literacy rate. So if you will compare this to your raw count on total population, you will see some of the areas, for example, this area, okay, which have higher literacy rate, right, but had, a lower value of the total count, okay, total literate count, okay. So why? Because because the denominator here is equivalent to the numerator, okay. Your total population, okay, your total population and your total literate population must be have the larger difference, okay. That's why it went to, that's why it has, sorry, I think I said something wrong. Okay, so this is your raw count on total population, total literate population, okay. So this has got some lower values. If you compare this table and keep it at 3, okay, third class, right? So if you will see here, the population count is total literate population count is between 132 to 456. Okay, but let's say here you have higher literacy rate. Why? Because your total population is, you know, here most of the population is literate, okay. Whatever the count is, most of the population is literate. So that's why we need to use the literacy rate, okay. So the percentage here of the literate people are more. That's why we have to use the literacy rate for our calculation, okay. So whenever you calculate rates on on any parameter, then such maps are called Choropleth maps, okay. So this is your single variant, univariate Choropleth maps. Okay, I'll provide you the link. You can read more about it, and again you can compare your literacy rate and the raw count on literacy, right? Raw count on the total literate population. Okay, so I hope things are getting clearer in your mind. Okay, so next, what if so? There is again a limitation with the literacy rate. Okay, what is the actually here in literacy rate? What we are doing? We are using the total population. Okay, this map doesn't give us the ratio of male and female literacy, right? If you will think about it, then this map just give us the sum of the male and female sum of the male and female literates, right? Literate people, and sum of the literacy rate of combined male and female, right? But something like 49 to 70%, let's say, for 49 to 70% of literacy in this area. But can you infer using this particular data that what is the proportion of male and female? No, we cannot. Okay, so that's why you need bivariate classification. You need two parameters. Okay, so let's see how those maps can be created. Any doubts? Any questions still here? Anything you want to be repeated again? Any concepts that is not clear? Okay, I think there is no question. So let's dive into our bivariate classification. Okay, so again I will duplicate this layer. Okay, duplicate this layer and I'll close this, and let's close the bottom layer as well, and let's use this literate copy at the top. Let's drag it at the top, and so as I said, we are going to use male literacy and female literacy rates. Okay, male and female literacy, not the counts, because we know there is a disadvantage in using the counts. Okay, we are going to use the rates, right? So let's rename it and say this is the male literacy rate. Okay, and I will again duplicate this layer, right click on it, and you find this duplicate layer option. Okay, and this copied version, I'll give it a name of female literacy rate. Okay, so we have the male literacy rate and female literacy rate. So let's make another formula. Okay, because we are going to create another formula as we did for our literacy rate. Okay, so again, go to expressions, right? Go to expressions here, and let's remove this part. Everything will remain same, okay? The brackets and multiplied by 100 will remain same, but in brackets we need total male literates, okay? M underscore lit, this parameter, this field, double click on it, and then divide it by total male population. Okay, total M. Okay, so double click on it, right, and multiply by 100. So this will give us the male literacy rates. Okay, click on OK, right? So let's classify this value, right? Okay, so I hope this is clear, and we have our classification based on the male literacy. Okay, right? So let's change the color. I'm going to use let's say blues. Okay, blues for the male literacy. Okay, so again let's classify the female literacy. Okay, I'll close the male literacy rate here, and I'll activate our female literacy rate layer. Okay, so click on it, and here again go to expressions using this E button here. Okay, and remove the center part, the expression which you have written within the brackets, and in fields and values find out this female lit, f underscore lit. Okay, f lit divided by your total female population. Okay, total f, right, total female population, and then click on OK. Okay, total female population. So again classify. Okay, so the values changed. Okay, right. So till here I think everything is clear. So let's keep it reds only, or you can also change the color, right? You can also use these reds if you want. I'll keep it let's say spectral. Okay, I'll use the spectral for female literacy. Okay, let's expand these two tables. Right now we have male literacy and female literacy. Okay, but now we want a map in which we can see the proportions of male literacy rate and female literacy rate. Okay, the proportions, right? We want to know the proportions of these two in each polygon, in each tehsil, in each district, in each village here, okay? So that we can talk about the actual literacy variation within our area of interest, okay? So how we can do that? First step, we will use the top layer, okay? And we will go to layer rendering, and here let's blend these two colors, okay? Click on multiply, okay? So click on multiply. So you see these colors are now blended, okay? I'll switch off all the bottom layers, okay? Otherwise all the colors will be blended together. So you have to blend only the layers that is the you are interested in, okay? So let's multiply the colors, okay? So the variation in colors, so see there are colors other than red, yellow and blue and all these colors, okay? So there are colors other than these, the colors that we defined, and these colors are created using the mixture or using the blending option, okay? Right. So because in our legend, in this legend we do not have this dark brown color, right? So we do not have much colors here, but this is the data. This data gives you an idea about the proportion of the male and female literacy rates, okay, which your total literacy or total literacy rate will not provide you, okay? You can take the screenshots of all these maps separately and compare it and better understand, okay? So that provides you a better understanding, okay? So these now, what if we want to create the legend for this map, okay? So this is your bivariate classification in which we used two different factors, okay? So what if we want to create the legend for this? So how we can do that? We have to use our bivariate legend plugin. So okay, so bivariate legend plugin. So click here, right? So I'll close this layer styling for now. Right. So you can keep your top layer and bottom layer of your choice. Okay. So there is no hard and fast rule for this. Okay. So let's keep the male literacy as a top layer and female literacy as the bottom layer. Okay. Right. So you are using the multiply blending here, right? Because you want to see the proportion, and these colors that are generated using the blending of these two layers tells us about the proportion, right? And after setting all these parameters, you should click on generate legend. Okay, so this is what you got, right? Okay, so let's do one thing here. Let's make some corrections with the color. Okay, so this is the basic idea. Okay, and now I want to show you one more thing. This is how you can create your bivariate maps. Okay, so code notation that this person, his name is Stevens Joshua, right? So he used this HTML code to create this color scheme. Okay, so we are going to use his color scheme, right? So for next, again double click on simple fill, go to fill color, and let's paste another value. Okay, I hope this is clear. So this is how our map will look like after blending this male literacy and female literacy. Okay, I hope this concept is clear at least. see, the problem here is that your lighter shade is at the top, okay, and your darker shade is at the bottom, okay. So let's reverse the colors and click on generate legend, okay. So this is the pattern that Stephen Joshua, talks about, that your lighter shade should represent the lowest value of two variables, both the variables, okay. Let me increase the size of this legend, right? And your darker shade should represent the highest value of both the variables. Now, what does this these rows and columns actually represent, okay. So your x-axis here on the legend, your x-axis gives you the bottom layer, okay, your female literacy here, right? And your top layer, okay, it gives you the male literacy, okay. This is always this is a standard that your y-axis gives you the top layer or whatever factor you are using in the top layer, and in bottom layer is represented by the your x-axis, okay. I hope this is clear, and also this is obvious from your the color symbol that you have used. See, gray, some shade of purple or pink, and gray and some shade of purple and pink. Okay, so this is your male literacy, this is your female literacy, right? So when you want to use this legend in your map, so you have to export this legend, okay, and you can save it as an image, right? Next is, let's understand, let's interpret our value. Okay, so if you use the classification that we have used here, so this is R0, this is R22. Okay, so one more thing, you have to keep the classes constant. Okay, so if it is 0 to 22, so this should also be 0 to 22. Okay, you can make these changes manually in your where you are performing your classification. Okay, so please try that by yourself. I expect that you can do that, okay, right? So let's say we have the classes from 0 to 22. So this is your 0, 22, this is your 41, and this is your 78, okay. In the same way, this the same classification applies in the y direction as well, okay. So if I talk about this shade, okay, if you can find the shade is, something like this, okay. So here you can say approximately 22 to 41% of females and 22 to 41% males are literate, okay. So that's how you interpret the proportion of data, how many. So I'll finish from my side, okay.